Okay, so we start. Okay, people that is online for the rest of the audience. Good morning. Hello, everyone. Welcome. AI, data and robotics at work. Okay, this is a dedicated workshop to discuss on this topic. My name is Ganix Lasa. Actually, I'm part of one of the sister projects that are all here that we are representing two different topics of the cluster 4 and why we suggested this workshop, right? The rapid advancement of AI-driven robotics is transforming industries, and human-centered design is a crucial factor, right? And we put focus on these specific topics because just to ensure safety, reliable, and inclusive solutions is one of the main and trendy technologies, right? This workshop is together leading European projects, 7 exactly. And the idea is all together here to explore synergies, share results, and address emerging challenges all together. As I have referring here, by fostering the collaboration between sister projects that are coming or are representing the digital emerging 0110, that is AI, data, and robotics at work, and then the pushing the limits of robotic solution, that is 0111, right? We are all here representing. And make sure that you are familiar with these specific topics, but just to clear up your mind, the one that is the 0111 is a bit more applied, focusing on AI, data, and robotics at work. Yeah, focusing on AI, safe, efficient, hybrid decision making, worker support, and so on. And pushing the limits of robot cognition is about actually pushing the cognitive limits of the robotics, right? So that's, let's say, the main difference. Here is in one single picture of the pitches. 7 different projects, the last 2 that are from the 0111, the rest from the 0110. And then after finishing the 7 pitches, let's try to have a enriching roundtable discussion all together, right? And about advancing human-centered AI and robotics, challenges, collaboration, and the road ahead, right? That's the idea. Then before starting with the pitches and so on, just a few key information, right? Actually, last week was launched and was presented the Eurobarometer, and we have here some representative numbers about how Europeans view the robots and AI, how positive they consider, right? Then how 84% of the Europeans think that AI requires careful management, and then the perception that is quite positive at the moment, right? And we see that the numbers are quite representative. But it's true that here we have another sample, right? And I will ask for your opinion, right? Before listening to the music and so on, I will ask which of these challenges do you think that will be the most critical in advancing human-robot collaboration? Here you have the QR code, and I will ask, and before starting off with the presentation, we will have just a sample, right, of this specific forum. And actually, if I jump into this slide, you will see the results that are live. Okay, improving trust, acceptance between human and robots, also some ethical and inclusive design concerns. Now, developing systems that are adaptable to a range of industries and tasks. Systems. So adaptability, right? I'm sure that they are keywords that we will discuss during the following hour, okay? And at the moment, you see that who is gaining, right? Between the challenges that we have listed, right? For sure that there are more, but at the moment. Okay, good. So nice sample. Okay, let's bring this information and put it into your pitch. Okay, so with no more delay, okay, Florian, please, the floor is yours, and we start with the first one. Okay, thank you.
Right, thank you very much for having me. So my name is Florian Pokorny. I'm an associate professor at Day1 Institute of Technology in Stockholm, and I'm presenting today the Softenable project, for which I'm. So Softenable, the title that we have is Towards Soft Feature-Based Manipulation Primitives Enabling Safe Robotic Manipulation in Hazardous Healthcare and Food Handling Applications. The two main application areas here, the food handling and healthcare, I'll explain a little bit more. The team that we've assembled to tackle these types of applications consists of several partners. So we have KTH, of course, involved. We're mostly focusing on method development for the combo object manipulation robots. We have DLR, who are in this project focusing on manipulator design, specifically for these types of challenges, led by Máximo Boas group. We have the Spanish Scientific Research Council with co-PIs Carmen Torres and Julia Boras working predominantly on cloth manipulation. So this relates mostly to the healthcare applications that I'll explain in a little bit more detail in a second. We have Technion, Israel Institute of Technology, with Professor Elon Rimon as part of the consortium, where the focus is more on analytic methods to handle soft object manipulation as well. And then we have two use case providers and experts. So on the one hand, we have a hospital clinic in Barcelona, who are experts in the area of healthcare applications, and Ocado Group, who are use case experts in the area of fresh food handling. Okay, so let me explain a little bit more of one of the use cases. So this comes from Ocado. So in their setting, they have an online ordering system where customers can ask for fresh food to order. And then there is a cold room environment where human workers today prepare, for example, fish to order. And each of these orders can be different. And in this setting, one of the problems is that there's a lot of variability between the types of objects that are being interacted with. Of course, food is not in standardized format. And also the environment is, in a sense, hazardous because these cold room conditions are quite uncomfortable for human workers to operate in. So part of the project is focused on seeing where can robotics really help in this setting to maybe alleviate some of the discomfort in these situations. Here are some illustrations of the type of manipulations that humans very regularly do with, for example, fish. And as you can easily tell, this is extremely challenging for robots today, both from a perception perspective, what is the state of the object that you're manipulating, and then also these objects being very fragile, being deformable, being slippery, etc. A little bit more about the second use case that the project is focusing on. For here, the topic is protective equipment handling. So in hospital environments, a lot of time is spent today in the dressing, preparing, and undressing of personal protective equipment. Especially during the pandemic, this was, of course, a huge burden on the staff, because often not only one, but two members of staff have to be active when you interact with the protective equipment. And the project is looking not at automating the whole chain, but only specific aspects here. So in the healthcare setting, we're looking into, for example, the piling and unpiling operations to prepare protective equipment for nurses that then mess with it. In terms of the types of impact directions that the project eventually would like to lead towards, we have identified three main impact areas. So we would like to work towards increased robotic handling in fresh produce, as I illustrated with this example, freeing of human resources to improve healthcare facility efficiency, particularly for the dressing and undressing of and preparation of personal protective equipment. And then eventually to have impact on sectors that involve robots in a shared environment more generally. Our approach in the project is very much stakeholder driven. So besides these two partners that are already use case experts, The project also incorporates feedback from the team and workers, so questionnaires, etc., that we incorporate in our work. And then this leads into the methodological approach of the project, which is very much focused on configuration space analysis and representation. Unfortunately, I don't have too much time to go into the details of this, but one of the core ideas here is to extend what we call caging-based manipulation to deformable objects. There's also hardware development happening within that. We'll see a video in a second. And then this leads to the two primary use cases that we focused on. And within these use cases, just to reiterate, we're looking at specific manipulation primitives that we'd like to target for automation, not looking at the whole process. Okay, the technical challenge, as many of you I'm sure are very aware of, is that to date, no mature and widely applicable framework for the robotic manipulation of soft, delicate, and deformable objects really exists. There's not really any mature technology that we can use for that in a general sense. So one of the approaches that we have been taking is to look at energy-based models. So here are some early results from a publication by my PhD student Isabelle DOR, who's been looking into analyzing what we call escape energy of deformable objects. Here's a simulation of a piece of fish. We're looking at how much energy is required to escape from a current configuration as the robot manipulates the object. We call this also a soft fixture. It comes out of a thread of research called caging-based manipulation in robotics. And we're incorporating that kind of analytic approach together with data-driven evidence. To look at some other results from the project, one important aspect we believe is to decompose the robotic manipulation problem into subparts that can be tackled with different methods. So one of the efforts has been towards developing a new taxonomy for deformable object manipulation. And one thing that we looked at in detail here, for example, is what kind of deformations really occur during real-world applications, classifying, for example, different states of bending, shear transformation, tension, etc., as a human worker or robot interacts with the material. So we're collecting data about this, trying to decompose the problem into more tractable subparts. Another aspect of the project is to incorporate various types of specific methods. So here's work by the team at Technion that have been looking into placement tasks, for example, using Euler's Elastica solutions to do very precise placement of deformable objects. So here's a mock-up in silicon of an object that would be, for example, a piece of meat as it's being placed by the robot. Another area of interest for us is the design of robotic manipulators. So the team at DLR has been working on variable compliance manipulators and custom indicators here that in a very non-destructive way can pick up objects. So here, for example, there's a support in the palm of the gripper. And the other special feature of this type of manipulator is that you have a support surface that can be used, for example, when you pick up the piece of fish and rotate it. So trying to avoid damage to the objects you're interacting with it. So some of the challenges, just to summarize, there are of course many challenges. In general, we believe that working with both data-driven and analytic methods might be the right approach here, where we use analytic knowledge about physics to the extent that we can and combine it with data-driven approaches. This kind of taxonomy-based approach and decomposing the problem complexity into subparts of interaction we're working on. There's a big need for versatile new platforms that can be used in industry, also in the designs. And one big challenge is really the easier adoption of these type of automation techniques, also in smaller industries, where you might have a problem that does not extend to a very large scale market. So these are open problems. We're not tackling all of them, but we're thinking about them very much in the project. Thank you very much.
Thank you. Thank you. Before jumping to the next one, I have actually a new question for you, man. Actually, it's related to this speech. That what do you think will be the most significant impact, right, in the solution of industries? And we have here different ones, right? Safety, physical strength, higher precision, reduced operational costs, Serial adoptions. Just keep it the same. Save. Noise. Quite balanced, eh? So yeah, your position is that yes, will be quite balanced, where the enhancing collaboration between humans and robots finally is the most significant aspect that you expect. Nice pictures. Thank you. So we jump into the next one, okay? That is FAIRWORK, that is presented by Robert. Please, floor is yours.
Good morning. Yeah, my name is Robert Woitsch. I'm the coordinator of the project FAIRWORK. And just to introduce the consortium, you don't see because it's far here. And we have here RWTH Aachen, a university dealing with the ethical and societal and also technical aspects. We have the two use case partners, CRF and Flex. I will introduce a little bit later. We have a company, Jotne, dealing with the data platforms. We have the research center, Uranium Research, dealing with data and human centers. More Collab from Portugal, dealing with agent approaches. And we have Omilab also here in the room. It's an exploitation and dissemination partner, worldwide network of laboratory experiments. Yeah, and I'm coming from BOC, which is a company dealing with management software, and we would like to use the AI to improve our management. Now, when we talk about AI for industry, because I thought, what is the key message I would like to present today? It's only this. The one is how to introduce AI into the industry. And the second is how to deal with sustainable information and how to produce reliable, sustainable information. So these are the only 2 points I'm introducing. Now you see pictures on the bottom. This is Flex, which is a producer of electronic devices. Most of the people are not aware that they are actually using devices from them. Everybody who has a mobile phone has devices from Flex inside this mobile phone because they make, for example, these GPS parts. So really worldwide acting one of the largest electronic parts producer. And here we have a factory from Romania and from Austria in the consortium. And CRF is also not so widely known. It's a research center from Fiat. You know Stellantis, so maybe you know Chrysler, Fiat, Maserati, Alfa Romeo, Jeep. So they are producing it, and we have the stamping factory, press shop to make parts for these cars. If you look up, you see workshops, which we did, and there we did design thinking workshops with scene to model. So we went to the factories and we made the workshops and asked the question, what do you expect from AI? And how you want to make sure that what you expect from AI actually happens. And then they put some pieces and papers, and out of the pieces and papers, we made models. And out of the models, we configure, steer, and monitor the AI. How? This is the way how we are doing it. So we have persons up there, and I can tell you one decision maker, how can I make a fair workload allocation? You typically have a production plan, and you start with the people who have the less competences, because it's the first you would like to put on the lines, which means the one who are experienced and powerful and the most capable person always get the last bit. Which is nice to have very quick and efficient production line, but which is not very nice to the person who is clever, smart, that's why it's there. So how to make the distribution fair? Another part is how to support the maintenance. Another part is how to ensure compliance with calibration documents. Another question is how to optimize under certain aspects, not fairness, not age, not quality, but also energy efficiency, etc., the production planning. So these are the questions we are dealing with. And we have the production lines and robots and factories, etc. And then, so what we said is there must be something, and we call it orchestration. Maybe it's a different and wrong word, but we said orchestration. If you have a better word, please, I'm free. But here we experiment how to bring human AI and data and robots together in a manageable way. So we started with workflows, we elaborated with agent systems, we went down to hard-coded, and we have the full bandwidth, and we are left and right, and I can show you experiments and prototypes for all different categories. This is what we look at it. And then we ask the question, how can we influence it? Models, with method, with laboratory experience, how can we influence it in different ways? Configuration, steering, only giving specifications, so the full scale. And on the other side, and I was very impressed by the AI on demand platform, we call it AI enrichment. Maybe now I should call it AI catalog. Yeah? Please forgive me, I did not foresee when writing the proposal, but this is, we have several different algorithms. And we are using several different algorithms in combination for the same question. So we compare constraint programming in addition with reinforcement learning with a multi-agent approach. And we're not saying the one is better or the other. We simply say we have the same problem, the same data. We are using two different approaches, and these are the results. We compare fuzzy rules and rules with large language-based approaches. If you ask why I'm crazy, yes, we are experimenting. So what we did is we extract now these three, call it contributions, suggestions for these 2 days. The first one is, okay, I can say something about solutions. We think about one or two, where we combine concept model, large language model for the maintenance. Maybe there is a second. We have 4 or 5 demonstrators where I said workflow allocation, maintenance support, compliance support. So this is where the use case partners demonstrate in the factory. We have additional 3 to 4 additional prototypes where we talk about generating quality documents, having a clean room, legal compliance checks. These are prototypes. So that, okay, thank you very much. We know what the AI is capable to do, but we don't want to demonstrate it now. And then we have additional 10 experiments where we really play around with different AI algorithms. We can put this on the table. If you think it's not mature enough, we show it somewhere in a prototype in the laboratory. Maybe you would like to see it. So that's what we can give. Trustworthy AI and watchdog. So we have a principle how this renegotiation can be implemented. And then that's a proposal and say, if you think what we are doing makes sense, maybe we can do some AI reference framework or architecture. Maybe you have a different word where we say, look, this is our architecture. We can have something similar, let's exchange. But my idea is if we can agree on a couple of boxes, and then we can say, look, we as a company, we can implement that box. If you can implement another box, let's try to integrate. And maybe there are boxes where several people implement. One makes open source, the other one is a research center, 2. Okay, let's competition of ideas, I like. Okay. Now, that's how the prototype works. If you zoom in, please apologize. I have a note under the bar saying for public reason, we cannot show you the real, let's say, data. So that's how to maintain a coffee machine. In reality, it's how to maintain or how to calibrate a camera on the quality lines. But you know, they are confidential data. So you have an interaction with the maintenance staff and the AI. So you have natural language processing, you have domain models, you have large language models and RAG. And this is what we mean with domain models. We have a model how the different applications are, the production line. And based on this information, you either search internally, it's an Excel sheet, there is a Jira ticketing system, and there is a Wikipedia. So we search for this, plus also the supply information for the guy who implemented this camera. And based on this concept model, the large language model identifies what the user wants and triggers different search agents. How to trigger different search agent, workflow, etc. This is something what we elaborate. I know the time is over, but I would like to present this as well, because this is the watchdog agent, and this I like. Now, this is worker allocation. I have several lines. Now it's line 17, line 18. Let me tell you, this is the one with the difficult part. So you have big parts of the car which are stamped, and 2 and 3 people need to handle this. It's sharp, it's dangerous, it's heavy, and you want to have a fair distribution. So you make an agent approach, where each worker has an agent to negotiate. I would like to be on that line, or I would like to be on that line. And then, okay, today I'm on the difficult line, but tomorrow I'm on the other line. So the agents start negotiating. You have a production plan. And then you have a full production plan based on all your indications. And then a watchdog says, yeah, but the age distribution is not satisfactory, and the gender distribution is not satisfactory. So you have an agent watching the results, showing it to the decision maker. You can say, okay, under this condition, I would like to renegotiate. And then you make a renegotiation, and you have a different distribution. And now you say, okay, these two criteria are satisfied. You can add another one, CO2 consumption, quality. So you can add different watchdogs, and you can renegotiate and renegotiate. And this is one sample how to bring, let's say, this into the decision making. I'm done. I'm just saying, look, this is our architecture, all the different boxes. If you have your architecture and you think we can match or we can change, but that's the invitation, please, whatever I told you, these two things, AI into industry, sustainable information. If you can agree on a framework, call it reference architecture, we're more than happy to work on such an approach. Thank you very much.
Thank you very much, Robert. As we did before jumping, right? I have another question for you that is basically about what we have listened now. That's it. Which aspect of FAIRWORK approach to improving working conditions do you believe will have the biggest impact on the future of work, right? And we have here, yeah, you can see it, but enhancing working safety, here again, empowering workers, with personalized AI assistance, reducing mental, physical workload. Basically, you see that we have lots of aspects in common, right? All the sister projects, and the impact here, according to your opinion, a bit more about empowering workers, right? Together with improving workers' well-being in overall, right? So thank you for providing your opinion. We jump, okay, into the next project. EARASHI, presented by Maintane, please. Thank you.
Good morning, thank you for joining. I am Maintane from Mondragon, and today I will share with you our experience in EARASHI project. Okay, so the aim of EARASHI project is to demonstrate how AI, data, and robotic systems can help users in their daily activities and tasks. We are putting our focus on safety and security, and the aim is to reduce accidents and to improve well-being. Okay. So this is our consortium. We are Inegi from Portugal, Ikerlan Aldakin and Mondragon from Spain, SIA Magnalogic, STM Brumo from France, AMS Flanders Make and System from Belgium, and finally Standard from Germany. EARASHI funds and supports 10 projects in the Horizon 2020 program. Okay, and here on the right side you can see the selected applications from Spain. Okay, this is a simple figure, but I want to share with you that enhancing well-being at work, job satisfaction, and increasing motivation at work not only helps employees, but also we can improve processes and we can increase productivity and quality. Okay. As a key result in the project, this is the human-centered design coaching methodology. It's a methodology that we designed that it's divided into three main phases. Okay, the first one, that is the first one, with awareness and knowledge for online webinars. The idea was to share the basis of human-centered design. Okay. In the second phase, that is the speaking phase, we did one-to-one monitoring coaching sessions with each of the beneficiaries, and here the idea was to enhance workforce capabilities through personalized coaching. Okay. Here we introduced the Human-Centered Industry Index, like it's an evaluation tool that we designed to evaluate the maturity of human centricity aspects in different companies, okay, but I will explain later. And finally, the last phase, that is the implementation phase, where we define the different KPIs to measure and optimize the different solutions that we have. Okay. Here, we ask them to fill again the human-centered industry index, and we did the evaluation of acceptance or adoption of the technologies by the end users. Okay. I want to share with you that there are two deliverables that are public. You can access to the website. So here you can see the QR. Okay. There is one of them is the Human Factors and UX Handbook, and the other one the guidelines for user design and ethics in industry. Okay. This is our human-centered industry index tool. That is a tool, as I told you before, to evaluate the maturity of human centricity in different companies. During the project, we asked the different companies to fill the questionnaire at the initial point of the project, in the middle, and at the final point of the project, to see the evolution of the maturity of human centricity aspects in the companies. It's divided in 5 main blocks. We ask questions related to overall question, like important questions. After a question related to human-centered industry, in the third block, we will do industry and ethics. We ask also about technologies, and finally about what are the expectations, goals, and needs regarding ethics. We have also designed different tailored technology acceptance questionnaires. First of all, the UROX questionnaire, that is a questionnaire to assess the technology acceptance and user experience of different people. The HRCAM, that is an adaptation of a classical CAM models. Okay, and here the idea is to assess the technology acceptance in human-robot collaboration scenarios. And after that, we designed the data analysis tool that basically is an Excel file where the beneficiaries only have to copy and paste the results obtained from the questionnaires, okay, and they obtain very visual results, okay, by charts and different graphics. But it's true that they are not used to handling this type of information and results, so that's why we designed a ChatGPT tool to help them to better understanding the results. They obtain customized feedback and report regarding the results, and that's why they have the option to understand and to define the main points to improve their solutions. Okay. Okay, our impact. First of all, we evaluate the maturity in human-centered design, and we provide tailored guidelines to improve their solutions. We created handbooks, guidelines, and so on that are available in our website. Okay. Regarding the implementation, we integrated acceptance questionnaires in several projects to see if they are adopted or not by end users. We help them to improve products and just some different solutions regarding the user experience and usability, because in some of the projects, the problem was that the interface and software solutions are not well adopted, so that's why we help them to improve their solutions regarding the usability aspect and UX in general. We demonstrate that it's a strong link between social science and humanities and technology. And finally, we raise the market readiness. Okay? They are now better equipped to scale the solutions and to understand our approach. Okay, and to finish, which are the challenges? I think that we have to stay closely connected to users. We have to understand their needs. We have to be with them and obtain information. We have to jump from intuition to structure, because some of the beneficiaries told us like this. Okay, we usually do some tests. Sometimes we ask them if the solutions are adopted or not, but not in a structured way. Okay? So that's why I put here that you have to integrate the human-centered design in the overall development in different phases, from the initial point of researching until the last one. okay, to test and to see if there are well adopted users. But it's true that there's a limited awareness and expertise on that, and sometimes the time and resource constraints are a reality. Okay, so they put more effort in the development and in the solutions instead of knowing, or researching which are the needs of the users. Yes. Thank you very much. I invite you to see something else in our website, and if you want to know something else, maybe let me know. Thank you.
Thank you, Maintane. Okay, so now it's your turn again. It's your turn. And I have dedicated question about the EARASHI, and it's about doing your thing. It's the most critical factor for small companies here. Maintane has been just referring to the SMEs, startups, right? To successfully integrate all these digital technologies that, as I know, the EARASHI is facing all these, right? All these challenges. So what do you think? It's about access to European funding, financial support, regulation, increased awareness and training, eco-design principles and some more principles, right? That could be collaboration opportunities with larger companies. But actually, it's all about the EARASHI. Here, access, data, digital tools, decision making. There are many challenges. And here is, as here we can interpret that is about creating bridges, right? And the funding together with simplifying regulation for this small and SMEs. Yeah. Good, thank you. So we jump into the next presentation. Yeah, GEYEDANCE, Gernot. Good morning, thank you.
Hello, everybody. It's fascinating to me how different the projects are, even if they're all in the same call. And maybe I'm putting another dimension to this portfolio. It's about robotic assisted surgery, as you can see here. We have tried to put the complete story of the project in the name. It's guidance, so it's a combination of guidance. That means the system is guiding the surgeon during the procedure, and it's about eye surgical procedure. So that's why we have this kind of intended misspelling of the word guidance. Let me start with the consortium. We have tried to really have it as small as possible, but still including the main players we have with Verona and Bern, two academic institutions that are very much into the AI development area. We have with atomique and research part of Zeiss company, two companies or two partners that are very much experienced in the translational research and development of surgical systems. And we have also complete the stakeholder list, two companies that are then intended to bring the system to the market. It's Precise from Netherlands and Carl Zeiss Meditech from Germany. And not to forget, it is user-driven, the design. We have the University of Verona covering all the clinical aspects in our project. Well, it's obviously about combination of robotics and artificial intelligence. That slide should show you how are we combining those two aspects. You see, we have identified three different areas how to implement artificial intelligence in this complete workflow of eye surgical procedures. Let me start with the more technical part. We have part of the project is to develop a sensing system that is assessing, interoperatively assessing the geometry of the eye, mainly of the retina floor. It turns out that those measurements are sometimes not 100% stable because it's a very complicated environment for the sensor. So that's why we're using artificial intelligence to basically to stabilize or to make the measurement more robust. So that's one part. we have, as it should be a guiding system, we have artificial intelligence based guidance of the procedure. So it starts from kind of semi-autonomous work, shared control work with a multimodal user interface for some of the procedures. For other procedures, we even are going towards autonomous or automated motion execution of the task. Finally, we have a third part, which is a bit kind of a bonus activity in the project, because obviously it's not that much connected to the robot. We're also using AI in order to do an analysis of the actual process compared with historic data in order to do kind of an assessment, the prognosis, how well the surgical procedure went. As mentioned, it's about eye surgery. So to be more concrete, it's about retina surgery. Why are we selecting that clinical application area? So first of all, it's a relatively high incidence procedure, as you can see here. And for us, even more important, it's a very challenging procedure for the surgeon and also for the equipment. You can imagine retina is one of the most sensitive tissues of the human body. We are having a very small area for the procedure. We are using very small instruments. So altogether, it's challenging. And what we want to have at the end is to have a safe and precise instrument manipulation in the eye. We were starting actually with two more concrete use cases. It's vitrectomy, which is removal of the vitreous humor in the eye, because that's a kind of a gel type tissues, and we need to first clean it in order to then have a unrestricted movement of the tool. And the second main part that we're starting is membrane peeling. Sometimes in the retina you have a membrane, and with instruments you're basically peeling away that membrane. I'm telling you that was the starting procedures, because at the end it turned out it's working on this kind of a platform technology, and we can extend it to a lot more clinical procedures in there. Sorry for the very quick slide about project objectives. Let me focus only on the blue lines. So we have, of course, some technical objectives. That means objective to create such a robust, reliable geometry measurement in vivo with these constraints I have already mentioned. Second objective, again a technical one, is we want to do this integration of artificial intelligence components in the robotic procedure in order to have a safe and efficient surgery. So I think that's obvious goals. What we even want to go a bit further, also as also required by the call, we want to implement everything into a robotic system platform setup that is not only being evaluated in laboratory setup, but also evaluated in a clinical trial, which is one of the biggest challenges in this project. And finally, of course, as we also have the companies involved, we're also trying to prepare the successful exploitation of the system in the international market. The impact, that's kind of redundant to what I have already told you. So first of all, main impact, of course, of the system is for the procedure, for the surgical procedure of our choice. That means for retinal surgery, we want to make procedure safer, easier. And we also want to have a kind of a knowledge transfer. At the moment, that's a procedure that is only done by very experienced and few very experienced surgeons all over the world. And with this AI component, of course, we want to widen the area of surgeons that can do this very challenging procedure. So again, that's very much focused on the application scenario, but of course, we also see some wider scientific economic effect. For us, it's definitely should be, at least at the end, one of the best examples for integration of artificial intelligence and medical robotics. And the important part is in a product. So we are not stopping with a prototype development. The idea is really to bring this to the market relatively shortly after a project ends. And of course, this should give a bit of a boost to the complete AI and robotics community in the surgical for surgical applications. Project results, there is that's like this some explanation. We have realized in the first phase of the project that the goal to have validated everything in the clinical setup maybe is a bit too far-fetched. So that's why we we thought we're splitting the work a bit into main parts. We have, as we call it, the research solution, and we have the clinical solution. Even the research solution you see here is already, of course, always evaluated by surgeons in a surgical setup with cadaver eyes in that case. And the idea is to have this research solution. In the research solution, we are testing new applications, see if that's something that's really helpful for surgeons, for example, and if it turns out that it's having high potential for the clinical procedure, we are then translating the outcome from the research solution to the clinical solution. And of course, if it comes to validation and preparation of the clinical trial, it's much more demanding compared to doing this evaluation in the research setup. So I think it's a good balance. Also, our researchers have fun with the research solution. Clinicians, of course, have more fun with the clinical solution. And the key in the project is to make sure that this pipeline is always working. That also brings me to the research challenges. There are some in different areas. First, let me start with regulatory environment. You can imagine surgical systems, medical technology is, well, I would say almost over-regulated, especially in Europe. It's not a real challenge. There are partners in the project that know the requirements quite well. The challenge for us is with the new medical device regulation. Preparation of a clinical trial is a bit more complex than it was beforehand. It's not the complexity that makes us some troubles. It's the unpredictability of the timeline, because sometimes you can do the full approval in, let's say, 3 months. Sometimes if there are some additional requests, it easily can be. And that's, of course, very hard for the planning. From technical viewpoint, our main challenge is, of course, we have very small instruments, and they're getting smaller. So between start of the project and now, I think there were again 3 jumps in making instruments even smaller. And we have to integrate the sensor, and of course, at some point there is a limit. We cannot go to 0.01 millimeter thickness of the instrument. So that's something we need to try to handle. Also here, of course, problem again is to make not to make any prototype of instrument for the research platform, but the problem is to make an instrument that is qualified for a clinical trial, which is a completely different story. Last but not least, and maybe that's the biggest problem we have seen in the almost 30 months that the project is running, is data. Yes, I mean, that's evident. Artificial intelligence systems need data. You all know how to deal with that. For a clinical setup, it's a bit more complicated, because we need real life data. We need clinical data. In order to assess clinical data, you have to have a system that can be used in a clinical setup. That means it's a system that must be fully developed, but you need the data for the development. So basically, the way you can do it is to do iterations, but with a 36 months project, it's not really possible to do those iterations. So that's also something we are struggling at the moment. If you ever plan to do an artificial intelligence project in surgery, don't go for 3 years, go for 4 years, because 3 years it's almost impossible. This is kind of chicken egg problem that I have mentioned. We are taking a small step in technology. We have to evaluate it. We have to make it qualified for the clinical test, then wait, and then doing assessment and so on. So if we would have time, no problem. In a short period of time, big problem. Next steps is, of course, we have still 6 months in the project to go. We want to finalize our preclinical tests. We want to have the final approval for the clinical test, and then, of course, doing the successful accomplishment for the clinical solution. And we still same problem here. Half of the interesting part is covered. We are going to develop additional technology and evaluate it in the research solution. Maybe there is still some technology going from the research to the clinical solution. That's it from my side. Thank you very much, and looking forward to the question that you have. Great, it was.
Okay, so everyone is waiting for the next question. Thank you. You know, dedicated for this project, right? In your opinion, what would be the greatest benefit of integrating AI driving assistant in delicate medical procedures, right? Not just even some of the realities, improving precision, reducing human error, reduce mental and physical strain on surgeons, enhance patient safety, quicker recovery times, increasing accessibility, and standardized training for new surgeons, through simulation. At the moment, improving precision, right? Reducing human error.
If you're an eye surgeon, you would then go for number 2 as well. So at least some percentage.
Yeah. So please. Thank you. Yeah. Get clear, huh? Yes. How is the feeling here? So let's zoom out and we jump into the aerial inspection robots, okay? Next speaker is Miguel Ángel from SIMAR project. Floor is yours. Thank you.
So hello everybody. I'm going to present you SIMAR. I'm Miguel Ángel Trujillo. I'm the coordinator of the project and also I'm head of the autonomous system unit at ICAPEC. So as I said, we are the coordinators and those are the partners of the project. We are 7 partners and maybe you can notice that the most important partners for us are the end users, that we have 2 petrochemical industry, one refinery, Chevron, and also we have BASF as we have a chemical plant. So what is the SIMAR? So SIMAR is proposing a new inspection aerial robotic system for large factories like these petrochemical plants. So here you have a video of previous results before the project. So here, what you can see is a aerial robot that is capable of landing on pipes, and in this case, the pipes were without insulation. Okay, so what we were doing there is that we were inspecting the pipes in order for looking for internal corrosion and so on. So every certain amount of months, years, you have to do this, and typically this is done always by human inspectors that in some cases, so you have to go very high, or there is a place that is unreachable, you have to build a scaffolding, and sometimes there is a ATEX environment, explosive areas, and so on. So what we are doing in SIMAR is quite similar thing, but we are focusing on insulated pipes, and insulated pipes are much more difficult because you cannot see what is inside the insulation. So in our project, we have human in the center, of course, and we have first, we have 3 functionalities. We have move the support that is there under that, and the understand. Okay, so the move is represented by these aerial crawlers robots. Okay, so we have boom, let's say, and with crawling robots for visual, X-ray, and pulse current inspection. And these are sensors or crawlers that are focused on insulated piping. Okay, so and this robot can work like in cooperation, like together or separate. So then we have the support that is, of course, the augmented reality. And we have different tools. One of them is HoloLens, Google, and so on. And we're doing what we're doing is we are putting this Google's pilot and also to the inspector, okay, in order to help them with, for example, situational awareness, in order to have more data for the inspector, so we can see more data than in a normal computer and so on. And the third functionality is the understand. No? That is represented by the artificial intelligence. We have for the pipes, and this is more, the most of the work is focused on the visual and thermal inspection. So we have cementation of the pipes, damage detection, localization of the damage, and so on, and also the interpretation and analysis of the X-ray and pulsed current data. And where are we going to do this? So as I said, so in these kind of factories, okay, so at the end of the project, so we will go to, that is going to be this summer. So we will go to a refinery of Chevron in France, okay, and we will perform the final experiments with our robot. So how this is working? So as a first step, what we're doing is that the aerial robot is just flying around, fully autonomous. So you can generate with your 3D model of the plant, you can generate the flight plans and so on. So the robot, what it's doing is with these visual and thermal cameras, is just looking for possible defects. No? But we don't know yet, but we don't know with precision because they are under the isolation. That's why one of the cameras that we're using is the thermal. So we're using, of course, as I said, so augmented reality tools in order to have give the pilot of the to go more information. Okay, so it's gathering, so it's like helping the situational awareness, and this is of course reducing operational risk. No? And for the inspector, so it's assisting inspector, so the inspector can see not only what the drone is seeing, but what it's doing and so on. So for the artificial intelligence, of course, what it's doing is that it's helping the inspector to process all that huge amount of data that we are producing with all the video flows and so on, in order to try to look for the, let's say, most probable areas where you could be able to find defects or corrosion, let's say, under the insulation. That is the biggest problem, let's say. So as a second step, so once we already know where is most probable that we can have corrosion, so we go with this aerial robot with the X-ray crawler, okay? So, and then we are first able to land on the insulated pipe, and once we are landed, so we are able, we can do it or not, but we are able to just leave the crawler there and use, for example, the aerial robot for doing another operations, leaving another crawlers or taking another crawlers that are working on the plant during the operation of this one. So what we're doing, of course, is, so once we have the crawler there in place, so we are taking X-ray pictures all over the pipe, okay? And of course, the artificial intelligence is processing all that information in order to look for corrosion, okay? And I didn't say, but the augmented reality tools, of course, are very important here, because from our experience, when you try to do like physical interaction with aerial robots, you need, the pilot needs a lot of information, let's say, because it's, let's say, a critical operation, because you are touching things, and aerial robots are not typically touching or interacting with the physical world. So, and the third step is, once you know with much bigger precision where the corrosion could be using the X-ray under the insulation, so you want to have, like, let's say, a complete map of that corrosion all around the pipe, all around that section of the pipe. So you go with this crawler that is the pulsed current crawler that is let's say it's using a sensor that when it's going around the pipe is capable of mapping the corrosion and the thickness of the pipe all over the pipe. So what are our key results of and the impact? No? So we have been able to have this first aerial robot in Europe capable of performing X-ray and also a complete pulsed current inspection. So just for you to understand, so we were the first ones in Europe having permit for having an X-ray equipment on board of an aerial robot, okay? And this is not easy, okay? So what is it doing? So it's reducing of course, cost, time, and time in maintenance, because we are avoiding rope access, we're avoiding scaffolding, we are also avoiding the workers' exposure to risky operation, like working at height, working in ATEX environments. And of course, if we are taking care of in a better way of the petrochemical facilities, so we will be able in the, let's say, long term to reduce environmental pollution because we will avoid problems. And so we think that as we will demonstrate all this in a operational petrochemical facility, we think that we are leading this new kind of inspection and maintenance role in the industry. So what are our challenges? So of course, to reduce weight and size of aerial robots. So I don't know if you were able to see, but the aerial robot that I was showing was around 30 kilograms and so on. This is, let's say, massive for what you are used to see or what you used to understand for drones. So of course, it could be able in the future to reduce the size. For example, we had a very big problem with, let's say, X-ray equipment are not light. So of course, as other people are saying here, so the training of the artificial intelligence, this is a 3-year project again, so we don't have all the data we want in order to train the models. Okay? And regarding the permits, so the cross-border permits, so it's difficult and it takes a lot of time to do these flying permits, but we have this under control because we have been doing this for a lot of time. But for example, for the X-ray, this is something, as I say, quite new, so nobody was doing this. So just for having the permits in just Spain, it took us around 2 years for the project. So we started at the very beginning, and we still don't have the permits for France. We are going to fly on July, so we are working on that. But it's really difficult. I guess nobody trusts drone with X-ray going flying around. No, but yeah. So I'm proud to say that we gathered this in Spain, and so they are trusting us with this. Okay, so so our future challenges as well are to focus more in, let's say, these inspection and maintenance jobs that are still very dangerous. So this is not only in the petrochemical industry. So we have this as well for, say, wind turbines, viaducts, many other industries that are requiring working at height or a dangerous environment. And so we think that the aerial robotics with this augmented reality and artificial intelligence tools are essential for reducing the risk of the inspection in this maintenance industry. Of course, always when they are not required to carry very big and heavy equipment. So we think that, of course, we will need to improve more and more the state of the art of this technology. But we think that we are in a good track. So thank you very much.
I have another question about SIMAR. This question. Thank you for the presentation here. In this point, what do you think is the most crucial benefit in combining aerial robotics with AI and augmented reality here for industrial inspection, right? Because safety for workers, reducing exposure, enhancing inspection accuracy, quicker detection, reducing operational costs, improving maintenance efficiency, or increasing adoption of automation in the smaller industries, despite the regulatory difficulties, right, that you are facing, then it's clear that it's a great impact. And here you see that the audience is quite. Okay, we'll move to the increasing safety, together with improving the maintenance operations. Right? So good. So now we jumped, if you agree, into the next two projects that are actually representing the 0111, about the robotics commission. And we start with Roberto Meattini, that is from Intelliman. Thank you, Robotics.
So hello, good morning, everyone. Yeah, I'm Roberto Meattini. I'm assistant professor at the University of Bologna. I'm going to present now the Intelliman project, which is about the application of artificial intelligence to multi-domain robotic manipulation. So Intelliman is a 42-month project which has been funded by European Union within the call Pushing the Limit of Robotics Commission, in the Horizon Europe framework. It is coordinated by the University of Bologna, in particular by our team led by Professor Gianluca Palli, which is the PI of the project. And the project started now more than 2 years ago and focuses on a specific research question, which is how can we apply artificial intelligence to robotic manipulation? How can we make robots able to learn purposeful, high performance, and safe robotic manipulation tasks? And the motivations behind these wide research questions are based on a few considerations, which are the following. If we want that robots make interaction with real worlds, we need to strongly focus on robotic manipulation, right? But in order to deal with let's say, the infinite variations and uncertainties of real world, we need to learn the manipulation task and possibly make this process as short as possible. And to do this, we had to rely on transferring some knowledge that is already present to robot, and also rely on some a priori knowledge, which means, in our view, to efficiently interpret the world by interacting both with object and humans, taking always into account the safety requirements. Okay, this means that the challenge of the project, therefore, is to develop a multi-domain AI-powered robotic manipulation system endowed with persistent learning capabilities in order to extract essential features from real world, decide which task has to be executed, and very importantly, to ask for additional knowledge when this is necessary to preserve or improve performance of the manipulation task. And to face this challenge, we have therefore built this consortium of 13 partners, which include universities, research centers, and companies around Europe, with the ambition of developing AI-based manipulation fields across diversified application domains. Okay? And therefore, to do this, these systems must generalize among different task structures. They had to exploit shared autonomy models to optimize human-robot interaction, exploiting both model-free and model-based machine learning, model-free and model-based approaches and machine learning approaches, and to guarantee failure detection in order to have safety requirements satisfied. Okay? And the Intelliman project, in this relation, targets 4 use cases, which are the upper limb prosthetics use case, in which advanced human-robot interfaces and shared autonomy models are pushed a lot, and this is led by the Italian Prosthetic Center email. Then we have the household aid robots in kitchen activities, in which manipulation planning and grasping of movable parts and objects in flatter environment is the context-specific challenge, and this use case is led by the Spanish Research Center EARASHI, the SIMAR in the audience. Then we have the robotic manipulation of fresh food, which focus on integrating AI-based solutions with advanced design of robotic grippers in order to handle this very fragile object, which is led by the British company Ocado. And finally, we have the 4th use case, which is about the industrial manufacturing. And especially here, we focus on machine vision and deep learning in order to robotize wiring tasks. That is to manipulate linear deformable objects like cables in order to automate switchgear assembly. And this is led by the Slovenian company. Very briefly, just one comment on the project structure in terms of work packages, in order to highlight how, in our view, the interaction, learning, and perception models, which are developed in methods and models which are developed in work package 3, are then translated into application related solutions by developing adaptive shared autonomy models and grasping methods. Okay, and then we have spread horizontally along the project developments the user and human operator acceptance studies, which is horizontally spread in the team. Okay, let me now briefly give you some development directions which reflect the concept that I've introduced in order to briefly give you some idea of the outcomes. So one framework that we are developing in the project is the co-adaptation between human operators and robotic devices by means of incremental learning methods. This is especially clear in the prosthetic upper arm prosthetic scenario, in which we have very nice learning curves between the human operators and the control of the robotic devices. In this context, then, it is also very important to have proper shared autonomy models. For example, in this slide, you can see some insight on how we exploit the probabilistic machine learning models in order to allow users finally regulate the grip strength while controlling wearable robot hands. And of course, in this context, it is also very important to properly advance the tactile sensing field. And we deal with it both in the industrial gripper case and with anthropomorphic and prosthetic hands by developing the proper electronic skills for tactile sensing capabilities. Also, we developed simulation environments, in this case, a very immersive virtual reality environment, which allow us to test the solutions that we develop, and also to make very rich psychological studies in order to evaluate the sense of agency, embodiment, and acceptance of these solutions very in advance by involving a group of subjects in the And this then has many benefits. For example, can be extended in the industrial scenarios for intuitive programming by demonstration of collaborative robots, for example. In this case, it's a multimodal advanced human-robot interface which allows to program trajectories and grasping for assembly tasks. And of course, if we consider then the grasping task in general, we have to go more at a high level of abstraction. For example, in the project, we developed geometry-based machine learning methods in order to generalize the grasping, whole body manipulation, and obstacle avoidance between many types of different objects with a unified approach. And then this, of course, goes together with also the development of very specific robotic grasping devices, which are necessary to be designed in order to deal with very specific grasping tasks, especially in the use case of flash food handling. Finally, I just want to show you also some solutions that we apply to robotic wiring tasks. We use machine learning, deep learning, machine vision to make wiring of switch gears, for example, for the routing, for the tracking the connectors, and also we develop some large language model in order to have natural language for the programming of these robotic platforms. To conclude, Now we are in the last phase of the project, in which we are performing cross integrations of the different solutions that we have developed, and also among the different application scenarios that I presented today. And with this, my presentation is finished. Thank you for your attention.
Thank you. Of course, I have no question. Our Day1, right? Here, nice to see how we are pushing the limits of robotics or cognitive robotics. We can have a real impact and right scenarios definitely. And here the question is, which aspect of Intelliman do you believe will have the most significant impact on improving worker conditions, right? In the next future, let's say we have 4 different use cases here, right? There could be assistance, reducing physical strain, real-time safety monitoring, personalized training, upskilling to intelligent systems, integration of human-centered robotics to optimize workflows and support the mental well-being and stress, right? Reduction at work. Here, but clear that before the people goes into the integration of human-centered robotics to optimize workflows, yeah, together with the assistant to reduce physical strain, routine tasks, and so on. Good. We are closing, but we are missing the last presentation from Alessandro. That is here again, representing the 0111, and in this case, sensor.
Okay, so thank you for having me. So I'm Alessandro, postdoc from the University of Oxford. So today I'm going to show you a quick overview of the Softenable project. So let me start with some motivation. So here you can see robots in manufacturing environments. So these machines are great, very repeatable, fast, so accurate. The problem is that they are usually programmed to do a single task with 0 or very little variabilities. You can also see that there is no human in the process because these are dangerous machines. But research nowadays is pushing to bring this robot closer to the human workspace. So, and it is challenging because we are moving from an environment where everything is known, everything is perfect, constrained to our environment, which is complex and constructed. And to do this, we need to solve a lot of challenges, and we mainly need 2 things. So first, we need to make a robot adaptable to different operational conditions, and we need to make them able to perform not just one task, but a multitude of tasks. And possibly, we should also provide a smooth way to interact between human and robots. And these are basically the objectives of Softenable. And to realize this vision, we believe that a key principle is sensing. So in particular, distributed proxy tactile sensing. Distributed means that sensor can cover the whole robot body, like a skin, okay? And you can imagine the robot as a kind of self-standing system, right? So sensors are on the robot, but potentially we would not need robots like cameras in the external environment. So why proxy tactile? Proximity basically is needed to make the robot aware of the environment, can map the environment, you can be aware of the surroundings. And tactile, well, because we are bringing a robot in a structured environment, so there is no way that we can always avoid potential. So with tactile, we can detect the collision and potentially react. And we are working on both hardware and software solutions to work with this. Just to give you an overview, these are the kind of technology that we are developing. So the first one is called Softenable, which is composed of sensors. So the tactile part is composed of capacitive sensors, while proximity are these sensors from ST, which are basically connected in series. So each one provides a kind of small point cloud of the environment, 64 points. And this is an example of the output. So the technology is flexible, so it can wrap and integrate it on the robot body. So this is another example of technology that we are developing. This is a tactile sensor, which is more cost-effective than the other one. It's a tactile sensor based on time-of-flight technology. So the sensor that you can see here are basically this type of sensor. And this is a soft medium. So when you press on the medium, basically you can triangulate the position based on the beam, the light beam effect inside the surface. How can we use this technology? These are some examples of application developed by the partner. We can map the environment, perceive human presence. We can use it for collaborative tasks. We can use it to detect collision and react safely without destroying the environment or the human around. We can use it for proxy-tactile localization of the robot with respect to the environment and vice versa, and of course for access control. So with this application, we want to target different markets, so starting from manufacturing, construction, logistics. But in this project, basically we are basically validating this in 3 use cases related to automotive, logistics, and agriculture. So very quick overview on each one of these. So this is about this use case is led by Center Research Fiat. So the idea is that human and robot should cooperate for a car assembly in a car assembly scenario. So here the task, the operator should assemble the rooftop of the car. The idea is the robot is holding the rooftop, and the human, together with the robot, will assemble, we perform assembly operation, maybe by adjusting the position of the robot manually to proxy-tactile gestures. The second one is led by Ocado, and the idea here is that they have this problem of moving bulky objects. Can be heavy, they can be large, which are objects which are not easy to manipulate just with a single gripper or with a single eye. So the idea here is that we can manipulate as a human would do, so using the whole body. Okay, and we're gonna use tactile sensing for this. So the last one is led by University of Maintane. So here the idea is that the robot should support the operator in harvesting operation, and the idea here is that so the robot should use sensing to avoid destroy the benches so that the vineyards. So this is just to conclude very quickly some of the challenges that we are addressing in this use cases. So the idea is that we use proximity-tactile sensor to increase the spatial awareness of both human and the robot. So for the human, we are putting sensor on the exoskeleton, and we use like a feedback, provide them feedback on the surrounding. We are developing models and controllers that can exploit multimodal feedback to make the robots adaptable to the dynamic conditions. And finally, to provide an intuitive human-robot cooperation, we are using proximity and tactile gesture. Okay, and this is something that we are not currently addressing on the project or just partially. So for sure, for future direction, we would like to bring the technology to a higher tier. We would like also to find manufacturing way to reduce the cost, especially for the proximity technology. And what we are not addressing here is safety regulation. What we so our methods do not quite comply with safety standards. And this is something that we would like to address in the future. So that's the thing pretty much short. If you have any questions, okay, here you can find some you are interested in something that viewers has to say so. Otherwise, if you have question.
It's nearly lunchtime, but I need 2 minutes to conclude, because here again, I have also a new question. Actually, have two. One specific to about testable sensors, right? That is about what do you think is the biggest benefit of integration testable sensor, whatever into industrial workplaces, safety? Here again, you see that we have lots of aspects in common. I think that we came across with a quite interesting picture with the balance between the projects that are representing the 0110 and 0111. Oh, sorry. Here again, the balance, and also quite side, yes, referring to the practical autonomy, improving decision making, right? And increasing productivity. Yeah, and half, let's say. Good. Before finishing, I have one question for you all. Actually, it was expected a round table, but we have no time to just to further discuss. Yeah, I encourage to all the audience to contact and just make the most of the time in this lunch video to come across and contact with all us. But yeah, as research advances and based on these foundations, let's say, what about new areas? And what if we look forward to the next 5 years? What is the most exciting aspects of human robot collaboration based on what on this sample and yeah, apart from this, that you believe that will have the greatest impact in the next 5 years? What is next? Let's say. What about if someone has any opinion, just to share with us, apart from this picture? Yeah, the picture says that all this will have a clear impact on the well-being of the workers and ergonomics, together with empowerment, skills augmentation, that actually is the next big trend, let's say. Good. Thank you. So this is the picture actually. And just to complete this, go up to almost the last slide. Sorry about this. Just to close, okay? So thank you to all the contributors, right? Let's not finishing the new one.
Thank you very much for the summary.
Yeah, that's it. A very quick recap in 2 seconds, right? But basically, remarkable start. I think that all sister projects have mentioned that somehow directly or indirectly we have hand safety and workers empowerment through robotics and AI. We saw different use cases. Also, we are looking for the collaboration between SMEs, startups, large industries, and we have here some evidences how to do it. Also, the challenges that we are struggling and the difficulties, and the technological integration in complex real-world applications with higher and lower TRLs. But yeah, with a nice picture with all these 7 representations. And what about challenges and about the future, right? That it's about the scalability and affordability of the solutions for SMEs, not just for SMEs, but just to make sure that all is integrated, cross-domain collaboration, for standardization, and so on. Data that was mentioned several times, availability, accessibility, just to train all the models and validation, and then the regulatory aspects, right? That we see that the speed, or yeah, in some cases, and the legal barriers are still in progress, and yeah, in some cases we are still waiting, right? And that's it. Thank you to all of you. Thank you. Enjoy lunch and see you around.
Okay, so I think we could start. So the bad news is that I was not supposed to be the moderator or the chair. The good news is that I will be, so we can start the session. I think we have 2, and I'm not sure if I have all the project right here. Okay, but let's start. Change the slides. So we'll start with the short presentations from the 5 projects that are here today on the human-centric AI. So they are sister projects. They are funded under the same call. Let's try to keep it short. So we have planned 6 minutes per presentation. So I saw, at least I was in a session in the morning where you spend all the time with the presentations. The goal is not to do this, so it's to have a discussion after the presentations. There is actually something to some information to collect and present in the last session of the day. But we can take 1-2 questions after each presentation, as long as they do not take too much time, because the idea is to save time for the discussion. We have some actually some questions from our side to guide the discussion, but of course we are open to discuss this. Let's just remind the goal for today is also to identify the key results from the project that we will highlight in the last session of the day. Okay, so as I mentioned, we'll make these quick presentations of the project. Not everything will be there, so that's why the discussion will be important. So we will have change order. Probably we can follow this order that is here on this project, and we might have to skip the human AI. Matteo is not here. We didn't arrive in time, but then we'll return to him in the end. So I will start myself with the coordinator of AI. Just one important thing. So we have here with us different representatives of the project. So there is most of the project, more than one person here, because the idea is also to foster the discussion around the project. So I think they can introduce themselves when they speak and when they intervene in the discussion. So not to lose more time, we'll start with the AI for RealNet project. So AI for RealNet is a project focused on the AI for critical infrastructures. So we don't lose the human side, and you'll see why. I'm the project coordinator. I have with me from RT, one of the representatives of industry on this project. And this is some kind of a summary of the project. So we are very focused on reinforcement learning. So most of the AI agents we are considering in the project is around reinforcement learning, when to target explainability of reinforcement learning, scalability of reinforcement learning with distributed and hierarchical architectures, but also to integrate human knowledge on it. So this knowledge-assisted AI is a way of integrating human knowledge on the reinforcement learning. It's not just neurosymbolic learning. We can have different ways of integrating human knowledge there. And we are considering these 3 different ways of interactions between human and AI. AI as an assistant, most of the use cases are around this way of interaction. Co-learning and autonomous AI, but in autonomous AI, we still have the human. But the thing is that the human becomes a supervisor or a director, the AI. And then we are applying this to 3 critical infrastructures: power grid, air traffic management, and railway. And for each one of them, we have digital environments to test and further develop AI. And then there is an evaluation where we cover a holistic evaluation. We started, as I mentioned, to have use cases. We have 6 industry-driven use cases. Those use cases are industry needs, so they were defined by the industrial partners on the project. We have, for each of these critical infrastructures, at least 1 industrial partner. In some cases, we have 2. And we apply the AltAI tool to derive requirements for trustworthy AI and also to include a lot of requirements and capture requirements for the use cases. So from the use of AltAI, we capture these requirements. These requirements led to metrics and KPIs to assess the requirements, and they were also included as part of the use case. So this was a formal process of describing the use case with the template and with the use of the AltAI, and everything was documented across this process. In the end, we found that the AltAI, as it is now, is not the best tool to do this. So we provided 5 recommendations for improving AltAI. One is that most of the questions are for end users, so in the final stage of development. And we feel the need when we were answering these that we need to have questions for the development stage or for early stage of development. And then the assessment process is quite long. If you start answering it at a certain point, it's very difficult to keep. In our case, the industrial partners engage in answering this because it's quite long, and some cases can even be a little bit repetitive in terms of answers. So this need to distinguish between relevant and irrelevant scope is quite important, and then to homogenize the questions and domain-specific questions is also something very important. In the project, we have a system view, and I think this is important. We see AI as a component of a social technical system where we have the human. So
The project is very interdisciplinary. We have social scientists, so they were addressing the human part, the human agent, how they assess the model as a human. There is also this important part of human-machine interface, and we see AI as a part of a global system, a big system. And part of the other conceptual framework, we see the AI part and then the human there, but we see this as a system. And what we want to optimize and integrate is AI in the whole system. And that part of the system is also the environment, the decision environment. So understanding how humans make decisions nowadays is an important point to integrate AI. So I will not go into details, we don't have time, but this is just to give an idea of the conceptual framework on the system. One of the results and one of the things is that if you have an AI giving recommendations, when it fails, and the human starts to see the failure, the trust will decrease. So one way of overcoming this is that you can have a way of trying to predict when we will fail and inform a human in advance. So for each scenario, you can tell to the human, I'm not able to, the AI agent can tell, I'm not able to solve this. And if something happens 1 hour from now, I will not be able to solve. And then you can even tell, when you link with the physical system, you can tell them in the power grid, if you lose this line, I cannot give you a good recommendation 1 hour from now. And then you start to build a relation of trust with you. So that's one tool, one feature to consider. Another one, and this will be soon in the GitHub of the project, is interactive AI. We are building on the top of the hypervision concept that was developed by RTE. And so you have the human is seeing alerts about potential problems on the grid that can be in real time or can be in the future. There is a timeline associated to it, and there is recommendations from the AI agents. And then the human can interact with the AI agent. So he can accept or not recommendations, or can he provide back other alternative actions to the AI agent. And then he can work with that. So this question of how we interface with humans and AI, it's something we have been doing. We started in building this interactive AI prototype to further develop these and further test this. And thank you. So as I mentioned, I used to have quick presentations. I think I respected the time. We can go, so from human AI, human eye. Okay.
My name is Roberto. I'm from University of Piraeus. I would like to present you the Humane project. The main aspect of this project and the core pillar of the idea and implementation is to design and implement an operating system in a way that we can interact between the algorithms and the systems. What we are offering actually, except of the operating system, is a platform when we can actually work and integrate every component that we may have arise in order to design different AI implementations. And since the most important factor, at least right now, where we don't have a lot of experience in AI, is the training and the material that we have in order to create that community that will enable them to actually implement something to the new era of AI. So going back to the Humane OS operating system, the basic, if you actually check the Wikipedia about the operating system, they mentioned there that the operating system is a software implementation where it transforms an entity to a system, to a service, to the so in our case, the actor, what we are trying to add to that implementation is the human. So the driver in our case, what we are actually offering and implementing, is a driver that transforms the human perceptions, the human intelligence into a digitized form in order to integrate it to the cutting-edge implementation that we are trying to provide. Since the overall idea of AI exceeds a European project, we actually based to these four paradigms, so active learning, short learning, or federation learning, since a bit, your subordinate learning, and the explainability of AI were based on the use cases that we have. We tried to enforce the platform to present that different cultures that each a paradigm has. The pilots are also distributed to the area of the concept that we can have. So we have cases from the healthcare, from the energy sector, from the smart cities, and the manufacturing. Actually, in the area of manufacturing, we are using federation learning, and we are actually focusing to the aspects of privacy and trustworthiness of the operation, and to the healthcare use cases. Mainly, the scope is to identify cases where the active learning can actually work and cooperate with the human element, where human element is not the doctor, but we can exceed to the people from the legal department or the people from the areas of the business sector, the cost. Finally, as I said in the beginning, the most difficult part is to present a platform where even an unexperienced person can actually use and understand how that obscure algorithm is working. That's why we tried to use user-friendly platforms, mainly open source, in order to have that flow that will follow the idea of the AI paradigms. That's why we mainly use, for example, Node-RED for no code or zero code cases or low programming cases. And since another aspect is the optimization to the lower level, we're using Kubeflow with all the libraries that every paradigm will use or can use for this case.
Thank you.
Yep. I'm going to say a few words about, we call it the PEER project, which stands for Hyper Expert Collaborative AI Assistant. So highlight some of the key elements of the project. So PEER is about, or our focus is on sequential decision-making problems. So this is the typical loop you then have, making explicit that an action or a decision is being taken. You come into a next state, but then more actions or decisions need to be taken as well. So for people familiar with planning or reinforcement learning, this is a traditional loop, but I will make this a bit more concrete by saying a few words about our use cases. So maybe I will start with this one, this use case from the city of Amsterdam, which is well known as a smart city. And they want to provide support for people with, let's say, who are less mobile to decide on which route to take. And deciding on a route immediately gives you an idea of what is a sequential decision problem. You can make a choice of a route, but then maybe on the way something might happen and you might need to deviate from your original plan. That will have, of course, an impact on how people perceive the AI assistant. But here, typically, people look at paths being provided by the AI assistant, make a choice, and are quite relying on the fact that this plan will be able to be executed. It's a bit a different story if you look at use case 2, that's referring to people shopping in these very, very large shops or order pickers, for example. Here, you also want to assist people, especially if they don't have too much time, of what is an efficient route to deal with the shopping list. But here you will see much more people deviating from the plan that was proposed, just because out of curiosity, they may be interested in some offers from that week, things like this. So it's let's say more volatile, and the plan you propose to the pickers. Then we have use case 1 that refers to, that's a bit more long-term planning. So it's they all have a bit different flavors, but all are sequential decision-making problems. So that's about storing goods in a warehouse, but let's say in a chemical context where your strict regulations need to be followed of which goods you can put where or which goods you can put close to each other. And the idea is to use the warehouse as good as possible. And of course, anticipating that more goods will need to be stored or will be taken out of the warehouse. And of course, at all times, following the regulations of how this storage can take place. So which goods you can put together, or maybe which goods need to be put in a cooled environment, things like this. And then we have our third use case here on top. And that's yet another one. It's also sequential decision making, but it's more about how to efficiently, let's say, fine tune a machine so that it fulfills the needs, the requirements of the actual user. So here you see, like referring to the production of medicine. It's not about the recipe itself. It's not about making the drug in the sense of coming up with the idea of how it has to be composed, but it's really the production. And there seems to be quite some cultural differences of what is an okay tablet in terms of quality of the tablet itself, how it should look, basically. And then in the middle, we see our methodology. So in a nutshell, our methodology is design, build, support, and learn. But what is now very important is that we have this co-creation of workshops. So the idea is that we already get requirements from the users, especially in terms of what do they expect from the AI before we actually build the whole AI solution. So that's dealt with in this co-creation workshops. And then, of course, we also need to validate how good we are doing. And that is there the Peach platform, which is all about evaluating, measuring the acceptance of what is being built. So I have just 2 slides very briefly on this tech cards, as we also use them, call them. It facilitates the interaction with the users before the AI solution is being built. For example, whether or not people expect that the AI behaves more like an advisor or more like an assistant, what is needed to get a reliable system according to the user. If you want to know more about this approach, there's the link, and you can download a document, and you will also see more information about the stack cards. And I also have a bit different cards if you want to have a look at them later on. It's AI ideation cards that is used by one of our social scientist groups to do this kind of exercises. And then a few words about the AI acceptance index. In a first stage, quite big summary has been made about all existing approaches to measure acceptance of AI solutions. So we took this quantitative approach with checklists and questionnaires. So there is a kind of integration study that has been done, and that is already in a first version of this Peach platform, which you can also consult. Now, currently, it's being extended to really deal with sequential decision problems, because now you have to be able to explain to a user, for example, maybe two actions look or two decisions look quite similar at this moment, at this point, but will have a large impact later on. So how do you explain this to users? This is what we are currently integrating also in this Peach platform, and that we are going to validate in our 4 use cases. This is the consortium. So you will see system integrators, you will see AI partners, social scientists, so also just like the other projects that have been presented, a very interdisciplinary consortium to develop these ideas. Thank you.
Thank you.
Thank you very much for having me here. My name is Arthur. I'm from Center for European Policy Studies in Brussels, so right around the corner. And I'm representing the only social science partner in the quite a large consortium of 16 partners of the Tango project. You might ask yourself, okay, fantastic. What is a think tank, a policy think tank representative doing in our fantastic workshop? Well, we are actually tasked on multiple and part of multiple Horizon projects focusing on decision support systems. And usually our role is about exercising assessment of ethical, legal, and socioeconomic implications of applied decision support systems and making it operational and then providing policy recommendations based on what's actually happening on the projects. So since we are talking about gaining trust, I will tell you about what we're doing on Tango regarding on technical side regarding gaining trust, but also trying to gain trust with a general relation and actually maybe trying to aim for uptake of this. So Tango is all about having 2 sides of the decision-making process. So it takes two to tango. Our idea is to have this cognitive computational loop between the decision makers and the system itself. So the general idea is to have a synergistic human machine learning algorithm, trustworthy, of course, that is with a feedback human machine coevolution process with the human decision maker, which entails our project works in a 2-stage kind of scenario. We have social scientists, mostly cognitive neuroscientists, working on cognitive theories relating how decision makers actually interact with the models. So the idea is to not get fooled by the algorithm as a decision maker, and on the other hand, to make the system in a way that would not amplify human biases while making a decision. So for example, not to trust too much so on and so forth. So, and then we use this knowledge, this actually theories that we are developing to create the systems themselves. That's why they work in parallel. And then on the side of it, we have our team that actually checks whether all of this is in line with the current trustworthy AI principles, while making a usable framework for ethical decision-making processes, which I will tell you more about at the very end of the presentation. So when we are developing this, we're trying to apply those systems in 4 use cases. As you can see, all of those use cases are high-risk use cases according to the recent AI Act. So prenatal well-being care, decision supporting system there, surgical procedures for aneurysms, credit lending, so credit scoring use case, and social welfare support for policy decision makers. And as you can see, all of those case studies actually, which is one of the first outputs of the project for the first 12 months, we think demand their own assessment, as it's nearly impossible to do that holistically at this point. So how does it look from the kitchen? So the cognitive side of it is about virtual bargaining, so based on game theory and mutual understanding in communication. And the other theory we're trying to implement is the how to perform the decision-making process in practice. On the other hand, we are trying to make it, of course, explainable, but most likely trying to avoid opening the black box, actually, at this point. So what we're trying to apply is neurosymbolic models in our technology stack based on this fantastic diagram. I can't go over everything in 6 minutes, so I already can pitch that our consortium already in first 12 months published over 24 papers about the project. So you must more welcome to check out our website on this. And the next step we would try to approach is not only to enhance the decision maker, the one decision maker, but to enhance a group of decision makers at the same time. The best example of it is, of course, a surgery. When we have, for example, multiple surgeons performing one operation. So we are moving from individual to shared decision making in later stages of the project. So moving from individual shared to then team decision making, which of course poses multiple issues also regarding, for example, human computer and interface communication and interaction. Perhaps not this. And our case studies have a goal of course, supporting women in making decisions in the prenatal period. We would like to help reach physical and mental well-being during and hopefully post-pregnancy as well. Our second case study is about, of course, surgeons trying to correct their errors. Then our credit lending case study, and I think the least developed one, our AI for policy making, which is using Serbian data to actually inform policies on academic endeavors. And this leads me to how are we actually analyzing all of this? Because the easy way would be to go through, of course, we are doing the trustworthy assessment, the ethical, legal, socioeconomic impacts, which will be probably compliance study on all of this, then doing the altai at the beginning and at the end of the project, which is, as already mentioned, not really useful. And then everybody would be satisfied. Probably the commission and reviewers will check on this and leave us be. But as I've mentioned, we work on multiple of those projects and realize this is definitely not the way of doing things. So what we are developing in Tango at this very moment to evaluate the trustworthiness and ethical decision-making is try to establish a methodology of actually checking impact of what's going on before we actually develop and implement the model, the decision-making framework, of doing it in a way that would allow us to take those inputs and apply it. The current problem on multiple projects is that everybody is using different methodology. Some people are doing ELSA, some people are doing ELSA, which is coming back. Some people are doing RRI. Everybody has different teams performing those studies. Some people have economists on board, some do not. Some it's only ethicists. Sometimes it's competition lawyers trying to do this. It's a mess. So what we are proposing is to actually take ELSA and, as recommended by the literature, implement economics into the mix, definitely, which is currently lacking, perhaps also paying homage to the recent competition compass discussion in the commission as well, and creating a two-stage methodology concerning, first of all, ontological background of the assessment. So why would we even do that? And then a framework, which is not a checklist, as I mentioned previously, just doing some literature assessments, but something operational to actually develop a framework. And just to finalize, the process we are currently implementing and discussing with other projects, and we will have quite a large gathering in a month or so on this, is to go in this direction, moreover. So understanding the case study, why we are doing it, for what purposes, and what resources do we have available. Then we try to map the breadth and try to engage consortium as much as possible, which in my experience in 5 years on technical horizon project, it's very difficult to get technical teams on board with this. Then when we have the mapping done, go to scoping, which is going in depth. So doing expert interviews, focus groups, co-creation workshops, of course, but actually doing stakeholder engagement on a large scale to determine the depth we are dealing with, not only checking, 700 publications of 3 literature reviews, which lead us nowhere, basically, because everybody's repeating the same thing over and over. So stakeholder and expert participation, which then only leads us to analysis, and then to mitigation measures and framework creation. I do not want to go more in depth. I'm open to questions. Thank you very much for listening to me, and see you.
We'll take questions after this last presentation. English.
Hello, everybody. Last but not least, the FEMIS project. My name is Dimitris Apostolou. I'm a senior research scientist at ICCS, which is a research institute associated with the National Technical University of Athens. So we are not the coordinator of FEMIS, but we are one of the R&D, let's say, partners on the technical side. We have, as all other projects, we have also social sciences partners in this project. This is the motto: trust AI your way, meaning, in a kind of personalized manner, in a kind of human in the loop manner, as all projects, we have a strong human side, and we try to address it, as you will see in my slides. So in Themis, we are developing a solution which goes beyond just a toolset, a technical toolset. As you will see in my coming slides, we're also developing a methodology as well as specific support tools, guidebook, etc. And we do this to assess, to help consultants or practitioners or AI experts analyze the transparency of their AI systems, focusing in particular in fairness, accuracy, and robustness. So these are the three main characteristics of AI trustworthiness that we focus in this project. But we also look into transparency, accountability, and to a lesser degree, explainability. So fairness, accuracy, and robustness are, let's say, our first-class citizens in terms. The whole approach is quite human-centered and personalized in a way, in ways that we try to take into account both implicit and explicit user preferences. So the preferences of the analyst, of the expert who is doing the analysis, we take them into account. And we try to provide both expert and non-expert users with clear insights as to how to go about the assessment of the AI trustworthiness. And as also stated by other projects, we also have a human-in-the-loop approach, and we try to take into account user feedback. So meaning user feedback from the on the recommendations that our approach is doing for doing the implementation, so whether it was useful or not, and so on. This is the solution set in a nutshell. So we have the system, we call it Trust Proofer. I have a next slide just for this. We have we are developing a process, we call it Trust AI process, which is, I would say, an overall framework of what explaining the various phases and steps that one has to go about in order to complete such an assessment. And it is a risk-based approach. So we take, let's say, key learnings from risk-based methodologies that have been around for many years. And it's also socio-technical. So it's not just, it doesn't include just technical steps like looking at the AI methods, but also important social aspects. To support this process, we are developing, actually we have developed the baseline guidebook, which is the methodology, a set of concrete instructions or guidelines for the practitioner, for the analyst, to undertake these phases. And what we think is quite unique, I think I haven't heard it much in the previous projects, is that we're developing a trustworthiness assessment cards. And we are inspired by the recent, let's say, trend or the recent approaches in data analytics and machine learning with the various data cards or method cards developed by major players like Google, etc. And we thought it would be useful to propose some similar cards, but for AI trustworthiness. And this is not something high-tech. I would say it's a low-tech approach, but it's quite useful to capture in a systematic way and disseminate and share essential knowledge about the trustworthiness of an AI system. And this is also useful. It's also used for transparency reasons, for maintainability, and so on. And finally, it's the actual system itself. So the system, in a nutshell, looks like this. It has at its core a knowledge graph, starting from the trustworthiness knowledge graph. And this, actually, we have a first implementation of this graph. We have what it includes. It's, let's say, kind of a knowledge model of the various methods that we found in the literature for assessing bias, robustness, and accuracy, these three aspects of AI trustworthiness. We have captured all this knowledge. We have represented in a kind of formal way. So we can say that this is our knowledge base, right? The knowledge graph. And then on top of it, we are currently developing an agentic framework that obviously uses also LLMs, but in a sense, try to mimic an AI expert. So it's a multi-agent system. We have various agents for the different aspects and different methods. And then these agents, through an LLM, are able to communicate with the analyst and in a kind of conversational way support the analyst, take advantage of these methods, help them tailor them, help the analyst also balance. And this is an important aspect actually that I don't have the time now to tackle it, but within this approach, we do take into account implicit and explicit preferences of the analyst to balance the various aspects. And in the end, through this conversational environment, the system provides recommendations about how to assess and also enhance, possibly enhance the trustworthiness of the system under test. These are the 3 case studies that we have, one from the healthcare, as most other projects, high risk use case, from the maritime industry, where we look, we have a partner, harbor, a port, and they have some AI systems mainly predicting arrival times of ships and other kinds of important issues for the harbor. And we also have a disinformation use case from the media sector. Okay, the project is, I would say, approximately halfway. And these are some early publications, so not so many as the ones I had previously, but these are just from our group, from ICCS. So we have a survey paper on trustworthiness, quite, I would say, interesting and very broad in scope, and some more specific papers about our approach. Current phase, we are currently developing the guidebook. As I said, we have a first baseline of the guidebook. We are also working on the trust proofer, the system, and of course, as all projects, tackling our pilots. What were not so advanced compared to the other projects that I've heard is the methodology that were used to assess the impact of our tools. So we are happy to learn from your approaches, and we can discuss later on, I guess, about possible ways to collaborate. And this is my last slide, a few info about our group at NTUA, ICCS. So we have established a lab within our lab, which is dealing with trustworthy AI through 3 projects that are currently running. Themis is the one that I presented. Faith AI is, I would say, a sister project. This is a research and innovation. This is an innovation action with some large-scale pilots where we again look into trustworthiness of the AI, and we are responsible for the use case that is assessing trustworthiness in education. So that's a completely different application scenario, but we're using the tools and methodologies developed in them. And finally, Extreme XP is a project, it's one of the data cores that is dealing with large-scale analytics based on experiments. So it's experiment-driven large-scale analytics. And again, there we're looking into some of the trustworthiness aspects of the experiments, mainly security, mainly transparency. So it's a quite more focused project. So thank you very much for your attention, and happy to take any questions now or later during the discussion.
We can all sit now there, and we have time now, half an hour. So to use the more or less half an hour we have, just to give you an idea of what we have to accomplish after this session. We actually have to identify remarkable results or insights from what we were presented from these 5 projects, and also challenges and innovation. So that's some of the outcome we want to get from this discussion. But we have time, so we have half an hour, so feel free to make questions to the 5 projects, and then we can save 15 minutes to be more focused on these tables. But if during your comments you can also point us already towards this information, will be good. So I don't know who wants to start with questions, comments.
This could be a question for who wants to answer. It comes up in different projects. I would like to know how you deal with differences in the users that you consider in your projects? Because it's different if you talk, for example, to a migrant woman, an older man. How have you dealt with that issue?
Go first.
Yeah.
Yeah. So in our project, in the Tennis project, we deal with this aspect for the creation of profiles, anonymous profiles of users. We call them also personas users. And this we have a twofold approach. So we both try to model users implicitly from their demographics, from their characteristics, but we also request explicit preferences. In a sense, we ask them to rate or to balance, let's say, how important it is accuracy with respect to fairness or fairness with respect to some other characteristics. So we use this information to model the users, and then this model influences the actual outcome of the software tool that we are developing. So in a nutshell, this is the approach for profiling of users and personas.
Yeah, in our case, it's a bit different. It's not so much about age, but the personalization is really at the core of what we're doing. If you think, for example, about the Amsterdam use case, it's about people with certain disabilities, but they have different, let's say, challenges to move around. So it's also the solution that, or the path that is being recommended, that has to take into account these personal challenges these people have. And so we see it also as a challenge from, let's say, the algorithmic point of view. How can you detect the exact constraints in an efficient way? So without 100 questions, for example, and how can you then also transfer them to new situations? But I fully agree that the way you explain something is different depending on, for example, age or other skills of people.
And so we have a second question.
I think these things are really useful and interesting. It's obviously very difficult to get reproducible results with people as well. There's such a risk of the framing of the question. You know, if you ask how important is fairness versus the alternative, I've forgotten, but people will have different opinions, maybe 9 o'clock Monday morning versus 4 o'clock Friday afternoon. So it's that relative thing. But I was more wondering on a technical level, is anyone looking at this as a complement to things like direct preference optimization to make algorithms more tuned to individuals, maybe to give it a starting point? Is there a kind of an AI angle before you brought it back in?
Okay, so in our case, I would say no. We don't try to change the actual algorithms. What we do is we through the preferences, we change the mix of algorithms that we propose for someone to implement in order to optimize the AI trustworthiness. So if one user is very much sensitive on the fairness of data, we propose predominantly the fairness algorithm and not, let's say, the accuracy ones. No, we don't change the actual algorithms, we change the mix of algorithms. This is what we do at least.
Without any particular reason. Seems like it's a random process.
But it's not random. That's what I'm saying. I'm trying to explain is that we ask the users to explicitly tell us their preferences regarding, let's say, fairness versus accuracy. If they value fairness twice as much as accuracy, you get the idea.
I think it's very difficult to find.
It's difficult. Yeah.
Can add something, because in AI for RealNet we are working with multi-objective reinforcement learning, and it's necessary in critical infrastructures because even the notion of fairness is not so well defined. For example, when you do train redispatch, how you measure fairness, because you don't know who is inside those trains, but you know it's a private business, so there are companies using the infrastructure, so you need to treat everyone in a fair way. So this multi-objective approach, I think it's very important on critical infrastructures. In the project we are doing that, It's a very classical approach. You have a Pareto function, and then when you do the reinforcement learning, you have the human choosing the preferred solution across the Pareto. So it's a very formal way, which might not be the best way when you have a human decision maker. So the way you communicate with him with the Pareto frontier might not be the optimal one. I think, Andy, you want to add?
Yeah, we also take this multi-objective point of view. It can indeed be by presenting the Pareto front, for example, to people, but it can also be lexicographic ordering or other tools. And then techniques like inverse RL, where you try to find utility function of the users, but you always have to do it in a way that you know that people are not replying in a consistent way. So it would be sometimes inconsistent. So yeah, that your utility function doesn't become non-existing. So you have to be robust against this inconsistent answers that you get from users.
Yes, thank you. We were actually talking quite a lot about the relationship between the trustworthiness of the algorithm and at the same time usefulness of it, because it's you can make everything very fair, you can make everything very accurate and trustworthy, and at the same time very useless. So it's you have to strike a strict balance.
Exactly.
That leads to we had a previous discussion. I mean, from the Equitas project, and we as well. I think 3 or 4 of you have also developed some sort of assessment tool related to it, and so have we. It seems that it's assessment tools all over, basically, like in this conference. This is sort of a project management discussion, and I hope we have also commission in the room somewhere, that how can we actually approach it at this, like it was something that we faced also previously, that not all the tools are useful for all the cases. This is not one size fits all sort of an exercise, and there is a good need to have a separate sort of ways of approaching. But have you been looking into the other projects, or having a constant dialogue on figuring out that what are you covering and how are they complementary, how on the other hand we can learn from one another, because this is exactly what we can do on this sort of things.
It's a difficult question. I think it's, if I understood correctly, not all the projects are in the same stage of development of this impact assessment. In our case, we started in the end of the first year, so we have 4 or 5 months of work. I don't know if in other projects it's the same or you are more advanced, but I guess we are building the role as we go on the project. But so far there's not been this complementary approach, but I don't think it's easy. The thing it's very domain specific. So the way you evaluate it, the KPIs, for example, in our case, we have 3 domains. We are defining KPIs, and we try to reduce the number of KPIs, because in the end, each domain have its own KPIs, and you end with 100 KPIs that is not useful. But converging to common metrics that then you can use on this impact assessment is very difficult. And we saw this in AI for RealNet. I don't know if from the other projects you have a similar experience.
Thank you for your question, because that's exactly what we are trying to do right now. That's why I didn't present everything on model cards, system cards, data sheets, and so on, because we are actually utilizing that and other tools on every project we are working on. So the project we are engaged in, we're trying to actually make use of the same tools everywhere, which are sort of, so we are trying to make them as use case agnostic as possible, and then come up with something which is use case specific to complement that. That's why on top of everything else, we're trying to develop the holistic methodology for ex ante and then ex post evaluation. And yes, we are in contact with other projects constantly, not only the consortia we are involved with, but actually reaching out to either other research projects, European research project, US research project, or even AI labs in Europe to try to come up with something together. So yes, that's exactly the stage we are in.
So that could actually be a result for this impact assessment. So we already have one. We need more tools. More questions, comments? Okay, we can focus on this. I mean, there are three things. One is these results. I think from the presentations and what we have discussed, we can easily come up with these three results. But then we have the research and innovation challenges. And I think one common point to these 5 projects is that all of them are research and innovation actions. So in the end, we'll reach a TRL of 4 or 5. And I think one thing is exactly what is the challenge to bring exactly these results that are not in the high maturity level stage. I think most of them, and to actually bring this to the industry. And I think there will be a lot of challenges from the research and innovation point of view. I would like to know your opinion and how you see as potential challenges that we might face during the project, but in particular also after the project duration.
At least from my point of view, I think it's difficult to this level to have a TRL different than the group that you just mentioned, especially the impact assessment, for example. But it's not only that it's something new, the legislation is something that constantly changing. The main issue is that we don't know what we are going to face in the following years. That makes it much more difficult to understand. And by the experience that we have from our project, the problem is not into one layer. It's like a cube. One cube will have the AA paradigms that we have to identify and have to be reflected through the impact assessment. The other layer is the use cases. Most of the projects are completely different, and we identified that the requirements that we have are fundamentally different. And the third layer is the perception and the people, where again, from country to country, from parameters and metrics that we can have, we identify that we cannot have something so generic as the one that we were expecting at the beginning when we were drafting the proposals. So for me, that challenge is something that I'm pretty sure that it's very difficult to be higher than TRL 4 or 5, for sure. It's not that we don't have the expertise, it's that the environment is in a way, in a fluid environment, we cannot have something better than that.
Any other opinions on other projects from the audience? Yeah, I can comment on that because we heard all about AI is moving fast. It's all what happened with large language models and recently DeepSeek. But in the end, when we go at the techniques they are using, they are not so new as we think. For example, DeepSeek, the secret is reinforcement learning, and it was actually made by the founder of DeepSeek in his PhD thesis, and it's not very different from what we do it in Europe. Maybe I think one of the points we have is that at a certain point we lose where to apply, and we give up in continuing exploring a certain algorithm or development. So maybe in these projects we have results that might not be exactly for that specific use case or application that we addressed in the project, but then they can be replicated in any other application and bring more value. So I don't know what is your opinion about this, but this could be, for example, reinforcement learning is the case. We are doing it for a specific use case. In our case, we have 6 use cases, but maybe there is value in other use cases that are not there, and we simply didn't found them because they were not in the consortium, let's say. So, if you want to comment on this.
Just again to mention something that let's take the history of the technologies that we have in the last year. So we have, for example, cloud computing, or which are robotics, advanced robotics. All these technologies, what we are actually trying to achieve, or what we are talking about, it's more or less technical. AI, it's something that changes the environment and you use you have philosophical questions that you have to have based on themes that I heard before. What is fairness? So in cloud computing, there's no things like that. It's pretty easy to answer. But what about things like the one about the philosophical question? And arise, and for sure, a developer cannot actually answer these type of questions. And I'm not sure it's not the proper person to answer.
Yeah, I agree. It should not be the machine learning engineer who takes the decisions. But the question is, to my opinion, more how do you facilitate then, for example, policymakers to discuss at least the trade-offs. So it's how do you facilitate the dialogue?
Just to advertise a bit our project, although I'm not very competent to talk about it, we have a group that are actually philosophers in our project that aim to develop what they call the moral compass. So it's going to be a software system, but it's heavily based on concrete philosophical approaches like virtue ethics, deontological ethics, and utilitarian ethics. So these are specific methods of philosophy. And in a nutshell, this moral compass will help, again, the practitioners judge whether, let's say, specific results or assessment results are within the moral boundaries defined by the experts. So I hope this is something that, again, could be a unique offering that other projects could take advantage of. In your approach. So, yeah.
In actual land, we also have philosophy, but they are addressing the risk. Actually, how you define risk and how you quantify risk, it's becoming non-quantitative, so it's becoming qualitative, and that's also an important challenge. So AI Act, how they classify risk is an open question, and I think it will remain. I don't know if on the audience, someone.
Yeah, please. I'm puzzled by this comment because I mean, the European Commission put a lot of money on AI, but not on developing technology. We are talking about the philosophical impact, the human-centric AI, but while the other countries are developing the technology, we are working on how to use their technology. So I think that this is not a very wise way to spend our money, because a nasty question for you would be, what do you think about the technology that you are developing in 5 years, 10 years? They will really change the way we live or not? Because if I go one step ahead on the technologies, I really change our life, or at the research that will come up later. But if we are still thinking about how people should use the technology, what is the philosophical, ethical implication? Well, I think that we are, I mean, everything is interesting because, of course, everything has its own value, but I don't know if that will be the main focus of Europe on spending money on AI. As I said, a nasty comment.
I probably can add to that one. Okay. It's not like, you know, we are inventing. The thing is that, like, more on other side, like US, they are making products, okay, and we are innovating things. So this is a huge gap between us. So we are always ended up ourselves up to TRL 5 or something. We can't go beyond that one. And we started having another innovation. This is our nature. We love to invent something.
Give an example. I'm not really agree. Give an example.
Yeah. So most of the research and the fundamental thing like reinforcement learning or any technological thing that you can look for, the history of them, they've been invented in Europe. Okay. But they've been, converted to product elsewhere in the US and, or in China. So what they are doing, they're really good at taking the TRL higher up very quickly. We are talking about ChatGPT today. Why? Because it's a product, it's accessible, people can use it. But we had the similar kind of thing, like, text mining and reinforcement learning, very low TRL within Europe. We never use it, or we never managed to convert them into products. So probably we need to do a little bit more on the high TRL, taking our innovation from our showcase and converting them to products so that we can use it.
I look at actually I don't know the history of it. So the interesting was it invented here was the European American invented. That's often how it goes. What's when you look at these indexes of high impact scientific paper, honestly, typically US universities, US and China really lead the way on the newest development. So Erle is quite around a long time. I think we need to, I'm not saying that we don't do good things, by the way, please don't. What I'm saying is that we shouldn't have any over belief that we're brilliant. We are really got to be very humble in this, because if I look at what the others are doing, I think they're doing at least as good as us. I think we have to improve. What we're doing right now is just not good enough on any level.
No, I absolutely agree with you. But my point was more, if we just think that, the UK, so Oxford, Cambridge, they have got really high index. Okay. Yeah. The point is that
it's becoming bilateral discussion. Let's but before going to one, just okay.
I don't know your name, but if it comes to reinforcement learning, of course, things have been done in the US, but very influential was Q Learning, Chris Watkins, UK, London. So still Europe, right? But I think indeed entrepreneurship is something completely different. But that's also another discussion, I would say. You see a lot of people, startups, when they become, I think they're called scale-ups, and then they move to the US. Also researchers bought in the US, I would say.
But I think,
I think we should be proud of what is happening in Europe as well.
Yeah. And we don't need to go to US. If you want to see a country that is doing well, it's Switzerland. We don't need to go to US. Switzerland, DeepMind have their research there. IBM, we have been collaborating with IBM. The research lab of IBM is in Switzerland, in Zurich. So I think it's not the question Europe against US. It's a very complex problem because it's member states' policy also. I'm coming from a member state that is not doing well in AI. It's not investing. True. It's not the fault of Europe or European Commission. It's a member state. But answering your question, because this question is fair, and I think that's an important point. But we cannot think in technology without the whole context and the social technical system context. I think a common topic to everyone is social technical system, because you can develop technology and humans will not accept it. In a critical infrastructure, for example, from our project, we have Bruno that is from the transmission system operator of France. Integrating a new technology in a control room, they are highly risk averse. So you need to completely address the whole context, not just bringing a new technology. And the US is full of cases where they didn't address the whole context and the technology failed. It's not in the news because we don't see the failures on the news, but it happens, and it happens a lot. One of them was the Airbus plane that was a clear case where they didn't consider the context, and it failed as a technology. But I don't know if from now they want to say something.
No, just wanted to add in general that these are two different topics completely. Do we consider ethical, legal, and societal aspects of what we do with the technology that we develop and then apply? And what is the state of development in Europe? Of course, we already closed the debate whether EU is in the mix or not. It definitely is. Even in frontier AI, right? The Minstrel model, for example, recently is a perfect example of that. But in general, to look at what Europe is doing, I highly encourage everybody to go to AI World, a data set we are curating at SEPS that is the best to actually give you access to who is developing what and why. But the question is, do we do it our way and in trustworthy way, or are we actually giving this power to others. No product of neither from US or China has entered our market and wasn't blocked by some member state. DeepSeek chatbot was blocked, of course, by Italy. Same happened to ChatGPT. Same happened to Threads by Meta. They just do not care about things that we care about. So if we wish to have our implementations of European AI in certain sectors, for example, caring about privacy, so on and so forth, we should develop methods that we deem acceptable. So I think these are completely two different topics, competitiveness in this area versus the values we would like to implement.
Very shortly to answer your questions with the quote, it's a very famous quote about that. It's the Brussels effect. If you check the recent history, you can actually realize how that the discussion changed not only Europe but also the world with the GDPR. When we actually enforced GDPR in Europe, everyone was fun about us saying that Europe is producing legislation and US is producing software. But think what's going on right now in the reality. Check, for example, California. It's even more strict than we are up here. So we're actually producing something, but I agree with you. It's different from the one that we expect, at least in the industry, but it's quite important.
Yes, Martin Serrano from Insight. I have to admit that I'm a bit lost in this conversation because we have seen 4 project presentations which are doing their best to deliver some prototype application solutions. I was expecting that we will see some innovation challenges and solutions that you have confronted. And the common element is hyper-intelligence, I guess. I mean, the element that is behind this hyper-intelligence in the chat, in the assistant, is the data space. Because everything, this intelligence doesn't come from a black hole. It comes from the data that is available. It's going to be provided by the cities, by the sensors, by the machinery, you name it. So I want to challenge the panel to tell us in one sentence what your project is doing in terms of data spaces, how you're benefiting from the space or from the delivery of this data space, how green and sustainable it is, and how we will advance with your technology the AI space in your domain, because obviously the specific domains can be very challenging. But if you can clarify those, then we're in the conversation, because this is what we are eager to listen today from 4 experiences. Very nice presentations, very good projects, but we still gathering. I'm still gathering to confronting myself. Like, is this a political issue? Is this more a generic or is platform technology? Please try to help on data spaces.
I can be very brief on this in the sense that you can dream about explanations that your AI system should give you, but you have to be able to realize them in a technical way. We are focusing on problems, as I said, sequential decision-making problem. So how to explain a plan to somebody, how to explain a plan B, things like this. So how can you get this from, for example, your reinforcement learning algorithm or your planner? Where is this information coming from? How do you translate it to the user? So, okay, we rely on maybe digital twins. That's not the core of our project. Our contribution to AI is not how to make more efficient digital twins. People are studying this, and we take it like the city of Amsterdam. They make their digital twin. Okay, we can use it. But the challenge, the contribution, the scientific contribution of our project is how do you...
What are innovations, scientific contribution?
Well, innovation, or whatever. The challenge is if you have a question to an AI system of why do you recommend me this route? Why is this step, for example, crucial? How can you generate a useful explanation?
Yes, hyper-intelligence.
Hyper-intelligence.
But you are the project.
We can call it.
My name is reinvented, recessing the
general
AI.
Intelligence, but yeah.
Anyone more? Because I think there is another question, but
I think you were very clear in your presentation.
Okay.
How to deal with questions related to risk.
we are not looking at the data space. If you refer to common data spaces, it's a little bit outside the scope of the 5 projects. The projects is very focused on decision making. Now we make better decisions. In general,
based on data spaces, right? You cannot do it with the algorithms. You need to train them. You need to train the algorithms.
I don't know all the use cases from all the projects, but from what I saw, most of the use cases you work with the data silo, not with the data space. In our case, in a critical infrastructure, don't think on a data space. You work with data from that infrastructure, and you support a human or a group of humans in making decisions. The same in healthcare and most of the projects on that. So we are going to high risk use cases and applications. And there, the notion of data spaces, I don't think is exactly the solution from my point of view.
But maybe it's a confusion because we're not talking about data universe. We're not talking about interoperability. We're talking about data space. All related to heat networks, all related to energy, all related to intelligence.
You were saying ChatGPT already does this, and there is a paper associated to ChatGPT that was the breakthrough, was human feedback on the reinforcement learning. And what these projects are trying to achieve is exactly those breakthrough, not on the human feedback, because this was already done. This breakthrough can be at the algorithmic level, can be at the legal level, a social level. Those are the breakthroughs that push us forward. So I think when we look at ChatGPT as something already done, we need to look at what was the story of it. And the story is papers with reinforcement learning, with human feedback. The attention is all we need, and that leads to the transformer architecture. Those were works from projects like these ones, PhD theses and so on. They were published, and they were 5-10 years later used to develop something that was innovative in US. So this is what these projects are trying to achieve. I can take one last question because I think I have to prepare this table. I don't know. I have to figure out.
The question was precisely to define challenge.
Yeah, no, I think but I think the spaces is a little bit out of scope for this panel, but there is other projects here doing that. Any last minute question? Comments? Okay, so I think we can end here, and I think we are on time. Okay, 3:45 on time. Thank you very much.
Les mandará una instrucción programa que lidera Iberdrola de conectar
Oh no, I actually had a project.
So it's not that bad, right? É para as coisas que você quer dizer. Não ainda para nós.
Trabajo y tengo que mañana
But that's not what you.
I like it. I'm proud of it.
How this hyper.
Well, it's from using planning on reinforcement. That's their expertise.